Hello.
Good afternoon, sir.
So, shall we start?
Sure, sure.
We welcome you all, and today's we our eminent speaker are Manoj Sahani sir. He has published 48 research papers in the journals, conferences, and proceedings and books chapters with reputed publishers like Springer and elsewhere. He also serves as a reviewer for many international journals of repute. He has contributed to the scientific committee of several conferences and associations. He has delivered many expert talks at national and international levels. He has organized many seminars, workshops, and short term training programs at PDPU and various other universities. He has also organized special symposia in an international conference, AMACS 2018, on fuzzy set theory, new developments and applications to real life problems, held at London in 2018. He is a member of many international professional societies, including American Mathematical Societies, Forum for Interdisciplinary Mathematics, Indian Mathematical Societies, and IANG, and many more. I welcome sir, and please sub present.
Thank you, Tejwani sir, for a very kind introduction. So, very good afternoon to one and all present online. First of all, I would like to thank the management of PIET for encouraging the faculty to organize a series of lectures for their faculties and students. I would also like to thank the head of the Department of Mathematics for the constant support provided to the faculties of the department. I would also like to thank the coordinators of this webinar, Ms. Payal Singh and Mr. Ashok Tejwani sir, for inviting me. Thank you all. So let me first of all share my screen. Is my screen visible, sir?
Yes, sir. The screen is visible.
Okay, okay. So the topic of today's talk is the fuzzy and the classical set theory. As it has been told to me, the participants here are the faculties as well as the UG, PG, and PhD students. So I will going to consider talk in such a manner so that I'm being able to actually cater all the needs of the UG, PG, and PhD as well as the faculty. Okay, so I will start with the basics of the classical set theory. Then I move on to the development of the fuzzy set theory, its importance, and then I will move on to the applications of the fuzzy set theory. Okay, so the outline of my presentation will be like this. First, the introduction of the classical, that is the crypt set theory. Then the introduction to the fuzzy set theory, its development, and the extensions of the fuzzy set theory, that is why the need arises of the fuzzy set theory. Then I will move on to the applications part, which requires the concept of the similarity measures, in which I will take into consideration the basic part, that is pattern recognition, and single period medical diagnosis and the multi-period medical diagnosis. And I will going to list some of the application areas where the fuzzy sets that is being used. Okay, so this is the flow that I will be taking into consideration in this talk. Okay, now I think everybody, because we have here the UG students also, so I will start with the basic, that is first few minutes I will go into the basic part of it. And I think everybody knows the development of the set theory is given by the George Cantor in 1870s. Okay, now this is the very important set theory. Why? Because whether you move on to any real physical phenomena, that is, if you consider any engineering problem or a science problem, you will going to encounter that is a term which we use it as functions. Now the function is defined based on the sets only. Okay, so whether you are working in a discrete environment or in a continuous environment, okay, you require the concept of a set. But have you ever thought of that real physical phenomena, that is in day-to-day life, whatever be the problems that we deal with, is the classical set theory is sufficient to deal with such problems? I will going to ask you in a time, okay, that is after few slides. Okay, so now everybody knows that the set theory is based on a concept which we call it as the law of excluded middle. Now what is law of excluded middle? Which says that a proposition can be either true or false. In a Boolean language, in a number form, we write it as 1 or 0. Now proposition is a logical statement in which you are able to say whether the statement is true or it is false. So which we call it as the propositions. Now this is called as a law of excluded middle, where the set theory is based on. Okay, but in real life situations, it is not so that we are able to say whether the proposition is true or false, but we need to represent it in the form of a percentage. That is, the proposition is 50% true, 60% true, 70% true, or something like that. And then you will going to counter me that there is one subject which we deal with, that is probability. Okay, which will come into the picture. Okay, so again we're going to see why this fuzzy concept, that is the need arises for the development of it. Okay, now the classical set theory, in which we define a membership function, there is various ways to represent the classical set theory. One is which we call it as representing the elements enclosed with a curly bracket. So if you see it here, just a second. Okay, just if you see it here we have listed the numbers, that is set of even natural numbers, positive even natural numbers. Okay, which we have written it in the form of a language. Okay, now this, if I say 2 belongs to set A, the answer is yes, true, which in the Boolean we put it as 1. Okay, now these are the elements of it, 2, 4, 6, 8. So that is X belongs to A, we put it as 1. If X does not belongs to A, we put it as 0. Okay, so the membership or the characteristic function, this value is actually belonging to 0 or 1. That means they do not consider the values between 0 and 1. Only the boundary values that is being considered. Okay, now if I ask you a very simple question, that is this rose is red? The answer is yes, that is true. Is this rose is red? The answer is false. Is this rose is red? The answer is again false. That means you can put it as 1, 0 and 0. Okay. Now if I ask you this, what about this rose? Is this rose is red? Now you will going to say it is partially. Okay. So partially you cannot say that is completely true, that is 1, or completely false, that is 0. So it can be 50%, it can be 60%, or it can be something else. Okay. Now such situations do arise in our real world. So we cannot use the classical set theory there. Okay. Now if I say, is this glass full or empty? You cannot say it is completely full, or you cannot say it is completely empty. Okay, you cannot say this. So it is partially filled and partially empty. Okay, so here the partially word comes into play. Now a very real life situation is that, where do tall people start? Okay, now if you consider the classical set, so if I say it start from this, that is from the last 3, you take into consideration that is tall men. Okay, now from 1 to 5 you say it is not tall. So if I ask you a very simple thing, that it is varying from 150 to 200. Okay, now the second one is 195 centimeter, it is 190, and similarly let us suppose it is 189. Then you take 190 centimeter, the person is a tall man, 195 again you consider it, 200 again you consider it. So that means 189 is not being considered. The answer is no. So if you put in the form of a classical set, you assign the membership function from 1 to 5 as 0 and the last 3 as 1. Now this is not feasible. So again, the classical theory will not be able to give you the proper reasoning to classify those 8 men, that is whether they are tall or whether they are small. Okay, so we're going to extend this concept. So if you see, we are using the qualitative words, that is tall men, high pressure, large profit, moderate temperature. Now these are the qualitative words. Okay, these are the qualitative words. In general, we encounter such words in our real life situations. Okay, in which the classical set theory actually properly will not be able to classify such problems. So the extension of a classical set theory that is being developed, which we call it as a fuzzy set theory. Now this fuzzy set theory is very, very similar to human thinking. Okay, and it takes into consideration the imprecise as well as ambiguous patterns also, which the classical theory does not consider. Okay, so if I say in a very simple word dictionary meaning, fuzzy means not clear, imprecise. Okay, but classical theory means precise. So fuzzy is actually the extension. Why it is an extension? Surely in a few minutes you will be able to actually identify it of your own. Now, who is that person who is actually responsible for that development of the fuzzy set theory? Now he is the person Loftizadeh, okay, from the University of California, who has actually given this concept in 1965 and generalizes the classical set theory. So that means fuzzy set theory is the superset of the classical set theory. Okay. Now, the Zadeh, when he actually developed this concept of the fuzzy set theory, he actually got a sharp criticism from the academic community. Nobody has actually considered or actually have praised Zadeh in the development of it. And the fonts that the Zadeh is actually using for the development of it is being said that the development of the Zadeh theory, that is fuzzy set theory, is simply the wastage of the government funds. And he is the person who has given this name, that is fuzzy set theory. Because this theory is actually based on the imprecision. At that time, nobody has praised, but now I will show you the data of up to 2015 that how many research scientists are working in this area, and every paper or the research or the new area that is being developed praises Zadeh in its development. So there is a sharp transition. What that has been criticized in 1965, that when he developed it, is now being praised by the research community. Now, how the development took place? If you see in 1965 to 1975, he actually broadened the foundation of the fuzzy set theory by developing its application in the multi-stage decision making. So I will be showing you one application of the decision making, that is the pattern recognition, as well as in the medical diagnosis problem. He has developed the theory of the fuzzy relations, okay, development of the linguistic hedges, fuzzy restrictions, all these things in the 10 years he has been developed and being supported by the research community also. He's not the single person who has developed each and everything. Okay, first few years he has actually single-handedly have developed many things, but in the years going ahead, many of the researchers have actually contributed in that, and there is a group in 1970 that is being formed in Japan who has started working in this area of fuzzy sets. So if you see the fuzzy logic controller developed by Mamdani in 1974, Dubious applied the fuzzy sets in the traffic conditions, the application that is being developed, and many industrial applications. There is a group that is being formed, as I have told you, in the Japan and even in Europe. That is the fuzzy theory at that time started getting recognition. So there is a lot of group that is being formed in Japan and Europe, where many industrial applications that is being developed. Okay, and from 1987, there is a boom that came, and number of multiple extensions of the fuzzy set theory that is being developed, that I'll be showing it to you. Okay, so why it is an extension of the classical set theory? Now, if you see this set X, you can see that is how many elements you have it, that is 10. 10 elements are there. Okay. Now, if I ask you, this is taken as the universal set. Okay. Now, if I ask you to define the Krebs set forming a circle, what you will going to do? You will take these 3 circles. Okay. Now, these 3 circles have the member shape, that is 1, 1, and 1. All 3 as 1. Okay. And all others that is rhombus, that is hexagon, octagon, triangle, and all others, have been defined the membership grade as 0. Okay, but if you define it in the form of the fuzzy set, then if you see this hexagon having the membership value that is being defined as 0.1, that means it is not completely circle, but it is approaching similar to it with a membership grade of 0.1, means 10%. Similarly, if you increase the side and this hexagon change to the octagon, then it is approaching towards the circle. If you increase the side, that means it is 30%. The membership grade is being defined as 0.3. And similarly, if you again increase it, that is from hexagon to octagon to decagon, then it is 0.5. And similarly, if you increase the number of sides, then it is 0.8. And for the last three, the membership grade is 1. Now, this is a more generalization of the fuzzy set theory, which actually assigns the membership grade to each of it. Not one, to each of it. Okay? Now, this is very similar to the human thinking. It is not exactly circle, but it is approaching towards the circle. Okay? Now, if you see this one, the second example of the fuzzy set. Now, if you see this X, this is neither belonging to the A set, neither belonging to the set B. Y is belonging to the set A, Z is belonging to the set B, but T is actually the element which is not completely belonging to the set B. Okay, so it is partially. So T belongs to the partially to the set B. So we need to assign the membership grade to it. It cannot be either exactly 1 or it can be either exactly 0. So the boundary is actually vague and ambiguous. That is for this. And in many situations, we deal with such ambiguous problems. Okay. Now this is the representation. If you see this, A and B, the membership value is defined as 1, and C and D, the membership value is defined as 0. So it is either 1 or it is either 0. Here, A and B completely inside A, it is being put as 1. D outside A, it is membership as value 0. C is at the boundary. So it is being defined the membership value as 0.5. Okay. Now, if I say for another example to make you understand about the difference between the classical and the fuzzy, a number close to 5. So 4 and 6 is a number close to 5. So we assign the membership value as 1. But this is not logical. The human thinking says whenever you approach towards 5, then it is the membership value will go to increase towards the value as 1 when it reaches 5, and when it moves away, it decreases. Okay, so this is very much near about the logical thinking. So that means the fuzzy representation of the membership value is actually in resemblance with the human thinking. So that is more appropriate to take as compared to this. Now, if I say the honesty of a person, okay, so there are 3 persons. If I ask you about the honesty of a person, the classical answer is yes or no or true or false. But the fuzzy answer is we can characterize into 4 or more than 4. Extremely honest, very honest, honest at times, and extremely dishonest. And the membership value that is great, that is being assigned is, that is 99, 75, 55, and 35. So it can be 0.99, 0.75, 0.55, and 0.35 in the normalization. Now, if I ask you a very simple question, what is the sum of it? It is greater than 1, equal to 1, or less than 1? The answer is the sum of it is greater than 1. Now, to make you understand the difference in a very simple way, if you do have the number of elements x1, x2, x3, okay, x1, x2, s3, 3 elements, let us suppose be 3%, okay, and you are talking about the honesty of a person. If you put it the membership related to the probability, then what the probability says, that the sum of the membership values of x1, x2, x3 should be equal to 1. But in fuzzy, it is not at all necessary that it should be equal to 1. It is not at all necessary it should be equal to 1. If I say the first person is very honest, 0.75. Second person is extremely dishonest, 0.35. And third, if I say extremely honest, that is 0.99. So if you add this, it will be greater than 1. So this is a very, very simple difference to make you understand that there is a difference between the fuzzy and the probability concept. Now, to make you one more example, I am taking it. That is, we have, let us suppose, 50 participants in this webinar, and the understanding of the participants are same. The answer is no. The answer is no. It cannot be possible. The understanding of the participants in the webinar will going to vary. Somebody do understand 70%, somebody understand 80%, somebody understand 20%, and somebody other. So we can assign the membership grade to each of the person of the level of understanding. Okay. So if you see what we have done it, we have assigned a membership value to each of the elements. So in the fuzzy, we represent the set in the form of an ordered pairs that I am going to tell you in the next slide. So what is the difference that you have understood? We represent in the Cripps set the element, okay, that we have it or not having it. But here we list all the elements in the form of an ordered pair, that is assigning a membership value to each of the element of the set. So it is a collection of element, it is a collection of ordered pairs for the set. Okay. Now third is inclusion of an element into S is a Cripps, that is it has strict boundary yes or no. And here in the fuzzy, inclusion of an element S belonging to S into F is a fuzzy that if represents with a degree of membership. Okay. So I think up to this point, you might have understood the concept of the Cripps and the fuzzy set. Okay. So if you see, the membership value is between 0 to 1. Okay, and it has been defined from the set of the universal set, that is every element has some membership value which lies between 0 to 1, including 0 and 1. Okay, now this is an example which I have given it to you before also to make you understand that let us suppose you have 10 peoples having the height from varying from 150 to 208. So the membership value is being defined as first 4 as in the Cripps, that is above 180 it is being taken as a tall man, and below 180 it is being taken as a not a tall man. So that is being the Cripps value is being defined as 0, which is not proper to assign it. But in the fuzzy thinking, we assign it in the form of a membership values for each of it. So this is more proper way to represent it as compared to this one. Okay. Now the most important thing is the fuzzy membership values, how to define it. Okay. Now there are various ways of doing it. The membership values, you can define it either by choosing arbitrarily. That means the membership values can differ for each of the user. but in general, it is based on the user's experience. Okay? Experience means could be different depending upon their experiences and perspectives. Or there are many artificial neural networks and genetic algorithms that is being known, or there are specific methods from which you can generate the membership values. Okay, but in general, what that is being used in the research community is we generally use the triangular membership functions, trapezoidal, piecewise linear, Gaussian, sigmoid, and many other functions. So I think you all know this figure. This is in the form of trapezoidal. So this is the membership value that we use it for the trapezoidal. This is the most commonly used, that is triangular one. Most commonly used in the research community because of the usefulness of the triangular membership functions. So most of the research papers, if you see, is actually using the triangular membership functions. Most of the research papers. Okay. Similarly, in some cases where these are not applicable, these two are not applicable, in that case we use the Gaussian membership function, which we also call it as the normal distribution function. So I think everybody knows about the PDF of it. So it is represented in the form of exponential, where the parameters that we use it, that is CSNM. Because of the variation of CSNM, this graph, the plot, that is being varied. If you see, we are varying CSM. Okay, so you can use with the variation of CSM, whatever be the membership functions you can, which actually suits your problem, you can use it. Okay. Now the representation in general, if you see the representation of the fuzzy set, the numbers can be represented in the either in the form of a discrete or in the form of a continuous. Okay, so in a discrete manner, if you have the elements x1, x2, and more on, okay, the general representation of the fuzzy set is in the form of a summation. This is the standard notation that is being accepted by the research community. Okay, but in the continuous form, okay, it is representing in the form of an integral. So this is the two standard notations that we use it for the fuzzy sets. If you see it here, the example of it, here, this is the example. That is the membership is being defined as 0.1, which is represented in this form. The element 2 with a membership value 0.3 represented in this form. This is a discrete way of representation. 3, 0.8 represented, that is in the numerator we represent the membership value and in the denominator we represent the element. Okay, so this is the standard notation that we use it. In the form of a continuous, we represent it. This is the membership value that is being defined, okay, corresponding to x. So this is the standard way of representation of fuzzy set in the form of a continuous manner. Okay, I'm not going into that part because this is something different. Now, the development or the generalization. So if you see, according to the situations and the need, where actually the initial development of the fuzzy sets that is being developed in 1965, many extensions that is being proposed till now. If you see it here, the most common that is being used is the interval valued set and the antinuistic fuzzy set. These are the two most common that is being used till now. And based on this, many more extensions that is being developed. The basis is actually this. Now this is being developed. This is being developed by Zadeh. Intinuistic being developed by Atanosov. Okay. So first development took place, that is fuzzy set. Then the extension is being developed in 1975, that is interval valued fuzzy set. And I will going to discuss what is interval valued fuzzy set. And this is more generalized as compared to the fuzzy set. Then there came a type 2 fuzzy set, extension of again a fuzzy set, intinuistic fuzzy set, interval valued intinuistic, that is combining these two. Combining these two concepts, that is the concept which is being developed, interval valued intinuistic. If you see, that is interval valued also used and intinuistic is also used. Then we have multi-sets, rough intinuistic fuzzy sets. Now I will take the applications of rough intinuistic fuzzy set, okay, in the multi-period medical diagnosis problem, which I have taken the in the further slides. Okay. Then many more that has been developed: non-stationary fuzzy set, hesitant fuzzy sets, picture fuzzy sets, Pythagorean fuzzy sets. There are more, that is ortho pair fuzzy set, and the combination of this is also being developed according to the problem, according to the real life problems that the research community is encountering. The development are taking place till yet. Okay, and I will show you the figure. I will show you the figure where up to 2015, that how many researchers are working in this area of fuzzy set, the generalizations of it or the basic concept of the fuzzy sets. Now I said to you that I will going to discuss only two things here. I cannot discuss all of it. It's not possible. That is interval valued fuzzy set. Okay. Now what it says, interval valued, it's a generalization of the fuzzy set. What it says, a fuzzy set whose membership function does not assign to each element of the universal set only one real number, but a closed interval of real numbers between the identified lower and upper bounds. Okay. Now see this graph. Okay. The horizontal is representing the elements of the universal set. Okay. Now if you consider the single element A, if you consider the single element A in the universal set, okay, now according to the fuzzy set, you assign a single number. Let us suppose if I assign 0.1, the membership value corresponding to A. Okay. Now if I ask you a very simple question, let us suppose that A be any person of any class. Okay. And the corresponding to that person, if I ask what is the level of honesty, you cannot properly able to say the honesty of that person is 0.5, but you will going to say in the form of interval, it will going to vary from 0.5 to 0.7 or 0.4 to 0.6. That is 40 to 60% it is honest. Specifically, you cannot say it is exactly 50%. So that means that is more generalized way of thinking, and it resembles the human thinking as compared to the specific one. So interval valued fuzzy set is a generalization of the fuzzy set. Okay. So if you see, it is simply the interval. A single number is changed to an interval. Okay. The next extension, that is intinuistic fuzzy set. Now what is intinuistic? Now this is developed by Atanosov, what I said, in 1986. Is a powerful tool to deal with vagueness. Okay. What it says, a prominent characteristic of a intinuistic fuzzy set is that it assigns to each element a membership degree that is membership value, and a non-membership degree, that is non-membership value. Okay, and thus the IFS constitute an extension of the Zadeh fuzzy set. Now, if you see in the Zadeh fuzzy set, we only consider the membership degree, but not a non-membership degree. This is not being considered. So this is more generalized as compared to the fuzzy set. Now see it here, understand it with a diagram. So what it says, we have the membership nu of AX, non-membership nu of AX, and this pi of AX. What is pi of AX? That is equal to 1 minus nu of AX minus mu of AX. Now this pi of AX is actually called as the hesitancy. What it means, if I ask any person, can you please actually tell the honesty of another person? What it says, 50% honest, 30% dishonest, and 20% I cannot say. I am hesitant to say about the honesty of that person. So that means what it says, 50% honest, 30% dishonest, and 20%, that is, he cannot tell about the honesty and dishonesty of a person. That is, the person is hesitant about telling about the honesty and dishonesty. So this is more generalized as compared to the fuzzy set. Okay, so here it is clearly written, that is, both membership and non-membership is being assigned to each element. If you see, that is membership and non-membership assigned to each element X, and it is a mapping from X to the membership value which lies between 0 to 1, and the hesitancy is being defined as 1 minus the membership and the non-membership. Okay, so I think it is clear up to this point. These are the basics points that one should learn it when start reading about the fuzzy set theory. I am not going into that part, that is fuzzy relations and fuzzy operations, because there are many things, basic things, which one should learn it if anybody wants to work related to the fuzzy set. These are the very basic concepts. Okay, but I am going into the applications part related to the decision making. Now for the decision making, you need a concept of a distance measure, and we know, everybody knows, I think everybody knows and studied in the UG level itself about the distances. Now any function is being defined as the distances if it follows the four rules. First, the distance between the two same object is 0 for every x belonging to x. Okay. Second, the property of symmetry is being defined whether we move from this to this, that is x1 to x2, okay, or x2 to x1, the distance remains same. Okay. And the third is the triangle inequality, and the fourth is the positivity. Okay, distance cannot be negative. Now this concept that is being used to develop an application in pattern recognition. Now pattern recognition, we also use it in a very important area, that is image processing. Now that is a part of it. Okay, that is pattern recognition. Now how this distance measure is actually helping in pattern recognition, that we're going to see it, because using the distance concept, we're going to develop one concept which we call it as similarity measure. That is how much the two objects are similar to each other. Okay, so similarity measure is an important tool for determining the degree of similarity between two objects, how much the two objects are similar to each other. Okay, so the study of distances, which I have told you before in the previous slide, and the similarity measure of fuzzy set continuous-tick. Now this similarity measure is actually, we use it in the case of fuzzy set, extended it to continuous-tick fuzzy set, extended it to intervalued fuzzy set, extended it to rough continuous-tick fuzzy set, and many more. Okay, and this lots of measure which helps in real life decision making problems. How? Okay, so we will study using this distance measure, that is pattern recognition and medical diagnosis. I have not taken consideration of the machine learning and image processing. These two I am not considering it here. Okay, but there are many research papers that is being available related to the machine learning and image processing. Lots of research papers are there. Okay, now I think everybody knows about the cosine formula. Cosine similarity, which we call it, is a measure of similarity between two vectors of an inner product space that measures the cosine of the angle between them. So cosine similarity, when do we use it? We generally use it in the positive space where the outcome is bounded in 0, 1. Anywhere our membership is bounded with 0, 1. Okay, our membership is also bounded with 0, 1, and I think you all know the value of cos theta lies between 0 and 1. So it's a closed boundary between 0 and 1. So if we have the two attributes x and y, the cosine similarity cos theta, we can represent it in this form, that is inner product of xi yi divided by norm of x and norm of y. I think norm, everybody I think knows it. I think everybody knows about the norm of it. I am expecting that you know the norms of it. Now this is x dot y inner product divided by norm of x, norm of y. So this is the cosine theta, which we call it as cosine similarity between x and y attribute vectors. Okay, now this is in the vector space. Now if I convert it into the fuzzy, then for each of the elements in the universe of discourse, that is x1, x2, xn, we assign a membership value to it. Can you see this? Nu of a x1, nu of a x2, nu of a xn. And similarly for the second one, B set, we assign the membership value nu of b x1, nu of b x2, and nu of b xn. So these are the two fuzzy sets of the universe of discourse x1 to xn. Now if I change this concept of cos theta having the inner product xy related to the membership function, then it will be what? Simple xy changes to membership values, that is nu of xn, nu a of xi, and nu b of xi divided by its norm, that is under root of summation I equal to 1 nu of a xi plus nu b of square xi. Okay, if you see the similarity pattern, what is that is being done in the vector space and in the fuzzy set space. Okay, now can anybody tell, this is related to the fuzzy. Okay, now what will be the changes that if I do it in the case of intinuistic fuzzy set? Can anybody tell? Okay, no problem, no problem. So I'm going ahead and I'm going to discuss at the end if somebody have some doubts. Okay, so the cosine of the angle, if you see between the vectors, is always between 0 and 1. So its value lies between 0 and 1. Okay, we have bounded it. Okay. Now for what I am asking it to you, it's an extension related to the intinuistic fuzzy set, IFS. This is related to the fuzzy set. Okay. And such concept has already been developed for all the extension that I have listed it. See, this is the extension that I have listed it. This concept is developed for all, but I am taking only few of them because of I think the time that is being given to me is of 1 hour. So I cannot consider the complete. Okay. This is the basic thing that I am giving it to you. If somebody wants to go ahead with it, he or she can write to me. Okay. So what I said to you, in the intinuistic fuzzy set, we have the membership as well as the non-membership. So the cosine similarity, if you see it here, that is cosine similarity for the intinuistic fuzzy set. Till now we have considered only the membership, but now here non-membership will also be considered. Here if you see, this changes, that is the non-membership is also being considered. Now for having the element x1, okay, if you do it for n elements, that is x1, x2, xn, the value of for n equal to 1, n equal to 2 of this will going to vary between 0 to 1. Okay, between 0 to 1. That means we need to divide with n. Why divide with n? Because the cos theta, the cosine similarity measure, cannot be surpass the value 0 to 1. So for each of it, for n equal to 1, n equal to 2, n equal to 3, the value of it can be between 0 to 1. It can be 1 also. Okay. So if I sum this between 0 to 1, so it will be like this. That is 1 plus 1 plus 1 plus dot dot dot, and the last value is 1. So we need to divide it with n to make it as 1, because the cosine value cannot be greater than 1. Okay, so that is why the division n is being taken. If the value of n is equal to 1 means only there is one element in the universe of discourse. So we don't need it. We do not need the summation part in that case. Okay. Okay. So I'm skipping this part. This is the basic of it. Now this is a cosine similarity measure, and it is similar to the distance measure. So if you see the research papers, I can list the research papers at the end, references. It has already been proved that all this, see, either you are talking about a fuzzy set, or see IFS, intinuistic fuzzy set, or interval valued fuzzy set, okay, all this or its extensions satisfies the distance property. And what is the distance property? What are the distance property? We have seen it, that its value lies between 0 to 1. Symmetry should be followed. It should be equal to 1 if A and B is equal. And the fourth is triangle inequality. All these are satisfied for all these cosine similarity measures. Okay, I am not proving it here. It has already been proved in the research papers. Complete proofs are available. Okay, so I have listed it here. That's all I have listed it here. The proof, you can do it of your own also, or you can see the proofs in the research paper. Okay. Now, this is again an extension of the cosine similar measure, which we call it as weighted cosine. Now, what is weighted cosine? Now, if you have the attribute elements as x1, x2, dot, 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 xn. Now, the contribution of x1, x2, and xn, it is not at all necessary that the contribution of all this should be same. It should not be at all necessary. Let us suppose the contribution of first x1 is w1, of w2, of x2 is w2, and let us suppose of xn is wn. That means the weight of each of them are different. Okay, it is not at all necessary. As an example, if I give you a simple real life example, the weight of your director of your university, what it says, is not same as that of the dean or the head of the department or the faculty or your senior. The words weightage corresponding from the director to the senior of yours will be different. So it is not same. Okay, so the weight corresponding to each of the element will going to vary. If it is same, then we put it as 1 over n. Okay, but the total weightage should be equal to 1. So if the Wi is equal to 1 by n, this weighted cosine similarity measure will change to nothing else but CIFS, cosine similarity measure. Okay, so again, it has already been proved. I'm not going into that part of proof of it. So I'm going directly into the application part. Payal ma'am, hello.
Yes, sir.
Can I take 10 more minutes?
Yes, sir. You can take.
Okay. So I'm going into the applications of the intinuistic fuzzy set. Okay. First is the pattern recognition. Okay. So for the pattern recognition, if you see the application, we'll be using the cosine similarity measure. Now this cosine similarity measure, a question will going to arise that whether cosine similarity measure is the only measure that is being available. The answer is no. There are various similarity measures that are available in the literature. I will be using other one also to make you understand, that is COT also in the coming slides. Okay, but first of all, I will be using the cosine similarity measure. Okay, so let us suppose you have 3 patterns C1, C2, C3. Okay, we have given 3 known patterns. Okay, and that patterns is represented in the form of a IFS. Now, if you see this, X1, X2, and X3, all is being assigned the membership and non-membership grade. Okay, now this is the C1 pattern. Similarly, the C2 pattern is being assigned, that is X1, X2, and X3. Again, what? That is membership and non-membership. Now, if you see, why I calling it as IFS? Because 0.8 plus 0.1, it is 0.9. So the hesitancy is 0.1 in this case. So it is the case of a intinuistic fuzzy set. So it is not at all necessary that the sum of the membership and the non-membership should be equal to 1. Okay. Now we need to tell these 3 patterns, which one is more similar to Q. So we'll be using this cosine similarity measure. Just we have studied it. So for here, how many elements we have it? So the value of n is 3. That is X1, X2, and X3. Okay, so we'll be putting the values here and taking first C1 with Q, then taking C2 with Q, then third C3 with Q. Okay, and finding out the cosine similarity, CIFS. Okay, and then according to the recognition principle of maximum degree of similarity between the IFS, that is the maximum value that we consider it. Okay, so just the calculation that you need to do it, and you will be getting the value of CIFS C1Q 0.9353, C2Q 0.9519, and C3Q 0.9724. So what is the maximum value that you have got it for the 3 that you have compared? The maximum value you will be getting is C3Q. So that means the pattern Q should be classified in C3 according to the recognition principle of maximum degree of similarity between the antagonistic fuzzy sets. So C3 and Q are more similar as compared to C2 and Q and C1 and Q. So like this, you are able to actually recognize the patterns by using the concept of similarity measure. Okay, this is one example of it. Now, if I take into consideration the extension of it, that is the weights we can assign it for each of the element, that is x1, x2 and x3, that is 0.5, 0.3 and 0.2. And again we do the find out the that is weighted cosine similarity measure. Okay, then we get a value 0.913 with C1Q, C2 with Q is 0.9404, C3 with Q it will be 0.9712. So again you'll be getting the maximum value is this. Okay, so that means Q belongs to pattern C3 again. Now if you change actually this weights, the result will going to change. Okay, now the next application is single period medical diagnosis. Again, this comes under a problem which we call it as a pattern recognition problem. So let us suppose we have a set of diagnoses, that is Q having 5 of the disease that a patient can suffer, that is it can have a viral fever, malaria, typhoid, stomach problem or a chest problem. Now what are the symptoms corresponding to this disease? It can be the temperature, headache, stomach pain, cough or chest pain. Okay, now we have assigned the patient, taken into consideration the one patient. Okay, and corresponding to that, that is S1, S2, S3, the symptoms the patient is showing, and we assign the membership and the non-membership grade. If you see it here, that is 0.8, 0.1, 0.6, 0.1, 0.2, 0.8, 0.6, 0.1 and 1.6. Okay, so this we have assigned it. Now if you see again, that is corresponding to what is Q? What is Q? The set of diagnosis, the disease the patient can suffer. So corresponding to the patient that can suffer, we have assigned, that is viral fever, correspond the symptoms that the viral fever will show is having this 5 S1 to S5. Similarly, malaria, the symptoms corresponding to it that can show is having written in the form of IFS, that is membership and non-membership. Similarly for typhoid, stomach pain and chest problem. Okay, now we're going to apply the similarity measure, that taking into P with Q1, taking into P with Q2, P with Q3, P with Q4 and P with Q5. So we'll be getting this value. Okay, now if you see this CIFS P with Q1 having the highest maximum value, so we're going to diagnose that the patient will be suffering from what? With a viral fever, according to the recognition principle. The chances of it is, again we can call it suffering from viral fever, as compared to the second one it can have is 0.8602, that is Q2 is having the malaria. So we can actually categorize it. So this is a single period. What it says, single period, that means we have taken into consideration only one time period. Okay, but in general, it's very difficult to identify by taking consideration into one time period. That means when a patient goes to the doctor, okay, and what does the doctor says? Just have you observed that from the last few days, what is the pattern? What are the symptoms that you have from the last few days, and then note down it, and corresponding to it, they actually identify it. And even in sometimes they say, just observe in the coming days what is the behavior of the symptoms that you have it. So that means the person actually notes down, let us suppose after every 12 hours, that what are the temperature, is the person is suffering from headache or not, is there a stomach pain, is there a cough, or is there a chest pain. Then every time it makes a table of it. And then after, what does the doctor says? Come to me after 1 week or 4 days or 5 days. Okay, now that is called multi-period. Again, this is called as multi-period medical diagnosis. Okay, so I will going to take just 5 minutes, not more than that, and then I will going to wind out. Okay, so I will be taking into consideration that is rough interneutic fuzzy set. Now, what is rough interneutic fuzzy sets? A very simple concept that has been changed here. If you see phi of nu of xi, now this is actually the lower bound of the membership and the upper bound, that is interval. In the interval valued fuzzy set, the lower bound and the upper bound that is being taken, and the average is being considered. So in the rough interneutic fuzzy set, again it's a generalization of the fuzzy set, which takes into consideration the interval valued fuzzy set also. So here if you see, it is represented by the average of the lower and upper bound. Okay, this is a similarity measure, and it has been proved also. This CRIFS for the rough interneutic fuzzy set follow the concept of distances also. Okay, now here the chord similarity measure that is being used, not the cosine similarity measure. Okay, I'm not going into the deep part of it, how it is being developed. I'm not going into because of the shortage of time. Otherwise, I would have told you. So I'm not going into that part. So this is a cotangent similarity measure. If you see it, this is a cotangent similarity measure, as there are other similarity measure that is also being developed, that is tangent similarity measure and others also. Okay, so this is the cotangent similarity measure that is being developed. I have already told you what is phi of nu a, phi of nu b, that is the average of the lower and upper bound of the interval valued fuzzy sets. Okay, this I have already told you. So what is multi-period? Now multi-period I have already told you that we're going to consider, that is for the patient, that is T1, T2 and Tn, that is the observations is corresponding to symptoms is being taken, that is S1 to Sm for different time periods. Let us suppose if I take it for 12 hours, then after 24 hours, then after 36, then after 48, 60, 72, like this. Okay, and we can create a table, and that table is actually required by the doctor. Okay, so this is more generalized as compared to the single period, but it requires a lot of calculations. So nobody in general does it, and the doctor actually diagnose you based on the single period medical, the diagnosis that they have do it for the single period only. Okay, so this is the disease, the table that is being formed corresponding to the symptoms, which is represented by Cij. This is represented by Cjtk, that is related to the time. Okay, so for the rough interneutic fuzzy sets, this is the representation Cjtk and Cij. So yes, the last thing is the weight vector of the symptoms. The weight vector of the symptoms cannot be same. If it is same, then it will be taken as 1 by n. Otherwise, if the weight factor is not same, we assign it as W1 to Wm. Okay, and if the weight vector of the periods, that means for the first day, for the second day, and for the nth day. Okay, the weights corresponding to it can vary. It is not at all necessary the weight in the first day and the weight for the last day will be same, but the total sum weight should be equal to 1. That should be equal to 100%. Okay, so we'll be using this algorithm. First we're going to calculate the cotangent similarity measure, then we'll be using the weighted measure, multiplying the weights, okay, with the cotangent similarity measure. Then we rank all the weighted measures mi for p with respect to di in a decreasing order and give a proper diagnosis related to the maximum weighted measure value. So we'll be using this. This is a table corresponding to the disease, corresponding to the symptoms, and the values that is being given in the form of a rough intuinistic fuzzy set. 0.6, 0.8 is corresponding to the membership, that is lower and upper. Similarly, if you see 0.3 and 0.5, that is lower and upper. Okay, and similarly 0.3 and 0.5 again lower and upper. Second one is the non-membership grade, and similarly we have done it for all. Okay, this is the patient corresponding to the symptom showing for different time periods T1, T2, T3. Okay, then using that formula cotangent that we have shown it, we have calculated for different time periods, that is W1 TK, W2, W1 T1, W1 T2, W1 T3, and similarly for W2, W3, W4, and W5 using this cotangent formula. Nothing but very, very simple formula, but a simple lot of calculations are there. Okay, now this for different multi periods that is being calculated, and then we have used the step 2, that is mi weighted measure. We have calculated M1, M2, M3, M4, and M5, and just in a decreasing order we have ranked it. So M1, if you see, it is the highest one, then second is M3, third is M2, fourth is M4, fifth is M5. So we can say from this the patient P suffers from malaria according to the maximum weighted measure value. So this is one of the concept that we use it, that is multi-period diagnosis problem, where this fuzzy concept that is being used. Okay, so it is not one of the applications, but there are many applications that is being there, where the fuzzy set that is being used: data mining, decision making, artificial intelligence, machine learning, pattern recognition, image processing, traffic flow, management, medical field, and this is some of the fields that I have listed it. There are lots of fields where the fuzzy sets and fuzzy logic that is being used. Now, what I have told you at the starting, if you see this chart, that is up to 2015. For the last 50 years, the development, that how much research papers, how the research community is working on it. If you see the graph that is being developed, that is being shown here, that is based on the Google Scholar, how many persons are working, scientific researchers are working on it. Similarly, this is a chart which shows that the most active country in which the area related to the fuzzy, most of them are working are the Chinese peoples, then the US, then Taiwan, then India, Iran, Japan, Spain, UK. Now this is an endless list. So if anybody wants to work on the fuzzy set, okay, so they can write to me, and these are some of the fuzzy, these are the journals and the conferences where the fuzzy related research work have been published. As you can see, the topmost is the fuzzy sets and systems. then IEEE International Conference on Fuzzy Systems, then lecture notes in computer science, including sub-series lecture notes in artificial intelligence and lecture notes in bioinformatics, and many more are there. There are lots of it. Okay. So these are some of the references. If anybody would like to start studying about the fuzzy sets, I request you to please go and read these two books. That is, one is the Zimmerman and the second is the Clear and Yuan. These are the very two good fuzzy related books for the initials. Okay, thank you. Again, I would like to thank the coordinators, the management of the PIET for inviting me. So if you have any questions, please feel free to ask. Over to you, Payal ma'am.
Yes, sir. Now I would like to request faculty members and students to ask the expert any questions if they have regarding the topic. Sir already asked this thing. If you have any questions, so you can ask him. Okay, sir. I think there is no questions. The session is very interesting, and thank you, sir, for sparing 1 hour with us.
Thank you, ma'am. Thank you, everyone, for patiently listening.
Okay, sir.
So, can I leave, ma'am?
Yes, sir. Yes, sir. You can.
Okay. Thank you all.